Hey everybody, Mr. Piercy here, and what we're going to be talking about in this lesson is how you write the equation of a line, particularly if you're looking for something specific, like you want it to be parallel to a given line and go through a specific point, or same thing but for perpendicular lines, or just, I don't know, just writing lines, writing equations of lines in general. So what you know from Algebra 1 most likely is probably the first vocabulary term that you see there, the slope-intercept form, where, let me go ahead and get a color here. Okay, so the slope-intercept form, y equals mx plus b, most people that go through Algebra 1 would be able to at least recite that probably for the rest of their lives, and just kind of keep in mind what the parts of these things are. Y, let's just go through them in order. That's an output. You know, that's like your dependent variable. It's a number. It's your output value. M, what you saw from your last lesson, that's your slope. Change in y over change in x. X, well, if y is the output, x has to be an input, and b is the y-intercept. So it's called slope-intercept because it uses those two particular things in the equation itself. The second thing that you see is your vocabulary terms is the standard form where it's ax plus by equals c. This is actually a little bit misleading, I think. They call it standard form because they have x and y on the same side of the equal sign, and this is useful for us if we want to be able to quickly determine what are the x and the y intercepts by substituting zeros in for x's and y, or for the x value and the y value. But generally, it's not what we think of, it's not what I think of as standard form usually as a polynomial is concerned. But I don't want to go off on too much of a tangent, but for the time being, just think of what standard form is when x and y is on the same side of the equal sign. But the one at the bottom here that's not included in the handout that you have, but is, I think, quite important to have, is the point slope form. So let me explain where the point slope form comes from. We know that the slope formula is y2 minus y1 over x2 minus x1. Well, what we're doing essentially is we're taking the denominator and we're going to multiply it on both sides of the equal sign. So here and here they wind up simplifying, and I'm left with m multiplied by the expression of x2 minus x1 to be equal to y2 minus y1. And all they really did to go from here to here is, well, that's an example of the symmetric property of equality, where we just kind of reverse the order that we wrote it. Now, here I'm giving you kind of I call it the Piercy version. You can also think of it as a calculator-friendly version, because if you are using a graphing calculator, you do want it in y equals form. So all we really do is take that extraneous kind of y value that's on the left side of the equal sign, that y1, and we move it to the right side. So now it's in y equals form. But not only is this a calculator-friendly version, this follows the pattern of pretty much every other function that we see. I'm trying to figure out where I want to write this here. This is what every other function, the way that they were writing, where I'm calling it the Piercy version or the calculator-friendly version, y equals, and then all that stuff. Uh, that is the format that every other function looks like, basically, when we're trying to transform it, especially if we're not using a graphing calculator. We have, for quadratics, the vertex form of a quadratic, where in this case, A is representing the same thing as M. The H value is representing essentially the same, it's just representing what the x1 is in the point slope form, and the K is representing the y1, where x, if you think of it, x is something horizontal and y is something vertical. That's what we're looking at here when we're talking about transformations. We're not going to do this, but for you guys, I definitely think it's important to see uh, what a little bit of the future holds. We can talk about absolute value. We can talk about uh, square root. Every other function, and I could keep going, but I don't want to add too much more to what we're already doing. Every other function that you ever see in algebra, whenever you start doing basic transformations, especially by hand, are going to follow that exact same format. So to me, it makes sense to include the linear function as well as every other type of function in that same format, because uh, it provides a little bit of consistency from function to function, so you know that they always all behave the same way. Now, moving on, let's go ahead and talk about how we're going to be writing some equations of lines. Now, I want you guys to understand, uh, here it does say write it in slope-intercept form, and a lot of times that will be fine. But I want you guys to understand, you can write your equations for me in slope-intercept form, or you can write them in point-slope form, where you say y equals, where you say it like that. Now this one is fine. This one is great to write it in slope-intercept form, simply because we can find the slope between these 2 points relatively easy by either counting it if it's on a graph, the rise and run, or by using the coordinates they gave us and using the slope formula to figure out what the rate of change is. But the other thing that's really nice is that they actually give us the y-intercept. It's very easy to see, not just on the graph, the fact that the coordinate 0, 3 says that we don't go side to side at all, so it must touch the y-axis. So looking here, if I plug the numbers that they're giving me into the slope formula, or if we just count the rise over run, we're going to see that this slope is a slope of -2. Now the y-intercept is, like I said, very nicely given to us to be 0, 3. So the y-intercept is just 3. So substituting the slope and the y-intercept into their appropriate places into the slope-intercept formula gives us y equals -2x plus 3. And that's pretty much all we would need to say. Now, if I wanted to, I could also say y is equal to uh, -2 parentheses, and what I can use is I can actually use the other coordinate. We can use the 2, -1 coordinate and write the equation that way. So I can say minus the x coordinate there, so I can say -2 for the x coordinate, and I could also say plus the y value, which plus a -1 is just -1. This is the exact same thing as that, but in point slope form. And we're going to be practicing that a little bit, so I just wanted to give it to you now since, might as well. So here, this is where we're getting into the idea of the parallel and or the perpendicular lines, keeping in mind from the last lesson that we saw, parallel lines have to have the same slope. Perpendicular lines have to have slopes that are opposite reciprocals. Now, here you're going to see the method that in the notes, the text that they're giving you here, we're going to look at how we would do this, keeping everything specifically in slope-intercept form. Now me, I'm flexible. I think you should be able to write your equation in any form, and writing it in slope-intercept form is fine. But a point slope form, a lot of times I think it's just faster, it's easier to do. So I want you guys to be exposed to more than one way. So the situation that we have says right equation of a line. Now it's giving us a specific point that it has to go through, and we want it to be parallel to the given equation, 2x minus 1. Well, because the slope has to be the same in parallel lines, then the slope of my new line also has to be 2, since the slope of the original line is 2. But now we needed to go through that specific point. So what we would have to do, we have to do a little bit of algebra to figure out, well, what is the y-intercept? So if we stick with just using the points or the slope-intercept form, if we stick to just using that, we have to do a little bit of algebra to figure out what is the value of b. So substituting the y-coordinate, the x-coordinate, and the slope into their respective spots, we wind up with this. Multiply the 2 and the 1, and then subtract it to the other side, and we get a y-intercept of -3. And so the final equation would be y is equal to 2x minus 3. Now, if we were going to do it in point slope form, okay, if we do it in point slope form, we don't have to do any algebra whatsoever. We know the specific point that it has to go through, and we already figured out what the slope would be by the fact, well, they already gave it to us. We just know that the slopes are the same, so if they say the first slope is 2, the second slope also has to be 2. So simply by taking the coordinate, the negative or the positive 1, negative 1, by taking that coordinate and sticking it in here along with the slope, we can write the equation very, very quickly. And we don't, and here is where we can stop. We don't have to distribute the two and then combine our like terms to simplify it into be slope-intercept form unless you have to. It's perfectly fine to leave it in point slope form. So this is a happy little answer right here if you wanted to do it that way. Now, I have experienced some students, a lot of times when I introduce the way writing an equation of a line in point slope form, a lot of students are like, oh, hey, that's like super easy. I'm glad you showed it to me, Mr. Pearson. But once in a while, a kid will be like, I'm not comfortable with it because it just looks different than what I'm used to seeing with slope-intercept. And if you want to keep doing it slope-intercept, that's fine. I'm perfectly fine. I'm good enough to recognize when you're giving me one equation versus another. I just want you guys to understand that. So at this point, go ahead and this is where you guys need to practice on your own. Try it out and see how you do. So pause the video or work out, pause the video so you can work out questions 1 and 2, and then when you're done, come back and check your answers compared to mine. All right, ladies and gentlemen, I'm hoping that you've worked out your solutions, and now we're going to verify whether you did it correct or not. So again, the first thing I want to know is what's the slope of the line. Whether I use point slope form, slope intercept form, got to have the slope one way or the other. So either using the slope formula or by counting the rise over run on the graph, we get a slope of +3. So now that I know the slope is +3, I can look very easily at the graph because they're giving me the slope or the y-intercept. We can just plug in the 3 for the slope and the -5 for the y-intercept and call it a day. If you wanted to write it in point slope form using the other point, the 2, 1, we would say still substitute the 3 for the slope, but I would substitute the 2 for x1 and the 1 for y1, and we would stop there. So there are the 2 ways that you could have probably written that the equation for that line. You don't have to give me both, just one or the other. So the second one, write an equation on a line that's parallel to the given line and goes through this specific point. Now this is the one that requires a little bit of algebra. First of all, you have to recognize, well, the lines are parallel, so the slopes have to be the same. And so here's my method. I'm just substituting the slope and the coordinate that we have to use, the -2, 5, into the point slope form. And the only math that I might say that I'm actually doing is just right here where I'm saying negative times negative to give me a positive. Well, if you do it in slope-intercept form the way the notes were illustrating, you have to substitute your numbers again, and you have to do a little bit of math to figure out the y-intercept is, then do another substitution. So take your pick. Which one you want to do is perfectly fine with me as long as you consistently can get the right answers. All right, so here, same idea, except now we're thinking about the idea that they're perpendicular to each other rather than parallel. So you have to remember perpendicular lines, the slopes, when we multiply them together, would produce a -1, or just remember that they're opposite reciprocals. So here, with the given equation, -3x plus 1, well, the slope is -3x. So if you identify, if you can keep in mind the idea that the slopes are opposite reciprocals, you should be able to just really quickly say, oh, that's the slope of the perpendicular line is 1/3. So here, there's the math that shows why it's 1/3. Okay, and so now, again, what they're kind of giving us here, all of this is to do y equals mx plus b. So we have to figure out what the b value is. So substituting the numbers, doing a little bit of algebra, gives us a y-intercept of b to be 1. So substituting the numbers for the slope and the y-intercept that we got, we get this y equals 1/3 x plus 1. And somewhere, I guess I didn't add that graphic on there. But let's go ahead and do the next part here. This is again what I would have done personally. Just take the coordinates that they told me that I have to use, 3, 2, and substitute them in the point slope form, and we would be done. So either way, let me go ahead and graph these on here. I thought I added a graphic here. So we have -3x plus 1. So here, 1, 2, 3 over 1. So the line kind of goes down like that. And so let me pick a different color for the perpendicular line. So we know it has to go through positive 3, 2. And it will have a slope of -1/3. 1, 2, 3. Oh, down 1, 1, 2, 3 right there. Down 1, 1. Down 1, 1, 2, 3 right there. So, ooh, I didn't draw that line very nice, but you get the idea. You would probably want to use a straight edge when you do it. There we go. Perpendicular lines that go through that specific point 3, 2. So go ahead and at this point, go ahead, pause the video, try figuring out what the equation of the perpendicular line would be for this one, and when you have your equation, hit play again and come back and see what you got. Okay, so here is, I have to know that recognize since the slope of the first line is +4, the slope of the second line has to be -1/4. Using the point slope form, I would get the equation, excuse me, -1/4, and in parentheses x plus 8, minus 2 outside of the parentheses, just using the given coordinate that we had to use, or using the, I hope if I hit the right button there, using the slope-intercept form, we have to do substitution one time, then do a little bit of math to figure out what the y-intercept is, then do substitution a second time. So again, I think the point I'm trying to make is, with this point slope form, all you have to do is substitution basically once and you're done. With the slope-intercept form, you have to do substitution, then do a little bit of math, then do a second substitution, which to me, why go through the extra work if you don't have to? Now here, this is again a very strong throwback to what you might have done in Algebra 1. Here we're basically we're modeling something, where they say, well, what is the meaning of the y-intercept, or you know, what is the meaning of the independent variable? So here you're just kind of putting some things on a graph. You might have been asked at some point, what's a reasonable domain and range? Because realistically, we could use every number in existence. However, realistically speaking, not so much. We would have to kind of limit it to something that's a little bit more realistic looking. So here, find the slope of the line. What is the meaning of the slope? Well, in this case, the slope works out to be 375. Okay, well, we'll talk about that here in just a second, what it means, but probably you have an idea already. So looking at the equation, or looking at the graph, we can figure out what the y-intercept is pretty easily. It's 500, but there's the math that would show you what it is. And so now substituting those things, we would wind up with the equation of 375x plus 500. Now the reason why algebra teachers, math teachers in general ask you to do stuff like this, interpret what does it mean, is because this is a very applicable thing to real life. You guys may not have experienced it yet, but at some point you're going to own things that are expensive and beyond your ability to fix that will break, like a car or an appliance, something where you're going to have to pay somebody to come out and fix it for you. So usually they charge you something just to figure out what the problem is, and then they charge you an hourly rate to get things fixed. So the flat fee that they charge you is like their cost. That's what we would think of as the y-intercept. And the hourly rate that they charge you to fix something, that's the slope, the rate of change. So in this case, the 375, the slope that we figured out, that's the monthly rental cost, and the y-intercept would be the deposit for when you want to rent an apartment. So 500 of deposit and 375 a month for rent. This is probably an out-of-date question because $375 for rent is very low right now. If I could find a $375 a month apartment, I would really question the kind of condition that it was in if it was only $375. So anyway, let's wrap this thing up here. Oop, I think I went too far. Now here what it's asking you to do, at the very beginning of the lesson when I was saying, okay, if you have an equation in standard form, if you want to graph it, really the easiest thing to do is, instead of trying to convert it into slope-intercept form, would be to just substitute 0 for x and y and then figure out what the intercepts would be. So that's exactly what we want to do. Substitute 0 for x and 0 for y and figure out what the intercepts are. So the x-intercept is at positive 3, the y-intercept is at positive 2. So if we were to graph it, we would just put points at those two places and with our straight edge draw a line through them, and hey, we're done. Okay. So here's another kind of modeling thing. This one is actually, there's almost a tie-in here for what you did with systems of linear equations in Algebra 1. So you're buying a magazine at a store. It costs $3 every time you buy it. Like you're standing in line at H-E-B, you see the Inquirer, and you're like, oh, hey, just pick that up, $3. But you could also buy a subscription to it for $18, and you get one every month for $18. So what we're going to try and do is say, okay, well, what do these things mean to us here? Okay, when is one a better deal versus the other one? So the yearly subscription is $18. Cost of a magazine one at a time is $3. So substituting these things into it, we want to see, well, where would they intersect? So if we graph these two lines, y is equal to 3x and y is equal to 18, we see that they intersect each other at the point 618. So that's essentially letting you know that if you buy 6 magazines at the grocery store or the convenience store, then that's the same amount of money that you would have spent to buy a year-long subscription. So as long as you buy less than 6 magazines, then buying them one at a time is probably better. But if you buy it every month, it would be better to pay the flat fee of $18 and get all of them for the whole year as opposed to paying it for $3 each time. So here is pretty much where we're going to wrap up. This is your final thing that I want you guys to do on your own. Pause the video, try answering these 3 questions, and when you're done, come back and compare your answers to mine. Okay, so here, let's say here we're kind of modeling again the cost of joining a health club. Well, what does the slope of the y-intercept mean? Well, the slope in this case would be the annual cost, $650 a year, and y-intercept would be $450 for the cost of joining it, which again probably is unrealistic. Although if I had to spend that much money for a gym, I would really hate myself for not going because that's a lot of money to waste. So here, just graph the two lines, and we have a slope of 0 if y is equal to 3, and an undefined slope with x is equal to 3. And we wind up with those two lines right there. And finally, going back to the magazine subscriptions, suppose instead that you paid $2.50 for a magazine instead of 3. Well, how many magazines would it take before they kind of, balanced out, or one was a better deal than the other? Well, if you compare the two costs, that would be equivalent to 7.2 magazines. So same thing, like if we graph these things, they would touch each other at the x coordinate 7.2. Well, since you can't buy 2/10 of a magazine, you can buy either 7 whole magazines or 8 whole magazines, and that means you'd have to round up, so you'd have to buy 8 magazines before the subscription worked out to be a better deal, as opposed to 6 when they were $3 a pop. So the main thing is, again, that I want you to kind of take away from this is, again, the idea of parallel and perpendicular lines with the slopes, whether they're the same or opposite reciprocals. Uh, and particularly the new idea here, well, maybe new, writing equations in either slope-intercept, but particularly point-slope. I'd really like you guys to try doing that one. I think if you do, you'll really find how convenient it is. And then just being able to graph them and do some interpretation with it. But as always, guys, thanks for watching. Any questions that you have, make sure you send them my way or drop them off in the comment section of the classroom. And until next time, thanks for watching and be good.